Good morning, children. Welcome back to chemistry class. We already completed 2 lessons. As per our ICSE board decided, this year you won't have lesson 3. So now I'm going to teach you lesson 4. The lesson name is Atoms, Molecules and Radicals. This is our video session 6. Our topic is, first we have to know atom. An atom is the smallest part of an element that takes part in the chemical reaction. Whatever the matter, we have 3 states of matter: solid, liquid and gas. In that, the smallest particle is an atom. That atom we cannot see through our eyes. Under the microscope only we can able to see. Here in this picture you have a structure of atom. In that atom we have protons and electrons. In center we have protons, and then the revolving around we can say it as a electron. Our next topic is valency. What is valency? The combining capacity of an element with other element is known as valency. For example, when individually it cannot be stay for a longer time, it can lose its energy, so it wants to be stable. That's why it is combining with other atom. For this combining capacity only we can say it as a valency. Different atoms can have a different valency. The valency of hydrogen is 1. Zinc valency is 2. Elements with valency 1, 2, 3 are called. If they have 1 valency we can say monovalent. In case of it has a 2 valency, divalent. 3 valency means trivalent. So it depends upon the valency. Those atoms can have different names. Here you have a sum of atoms and their valency. Ammonium valency 1, chloride, hydroxide, chlorate, bicarbonate, bisulfate, permanganate. So all these are having valency 1. Barium, magnesium, cupric and ferrous. These are having valency 2. And aluminium, antimony, boron, ferric, phosphate and nitrate. These are the atoms having the valency 3. Next, molecules. What is a molecule? A molecule is the smallest part of an element or a compound that can exist independently. So here in this molecule we have 2 or more molecules combining together. So we can say it as a compound also. It can exist independently. Only a single atom cannot be stable for a longer time. So these atoms combining with other atoms to make a compound. These compounds are very stable for a long period of time. So either we can say it as a compound or else a molecule. Here in this picture we have an example of molecule. Then when an atom of an element combines with another atom of the same element, a molecule of the element is formed. Here we have a formation of hydrogen molecule. So 2 hydrogens are combining. Here 1 hydrogen and then this side 1 hydrogen. So 2 hydrogens combining. Here while the combining 2 atoms are same. That's why when an atom of an element combine with another atoms of the same element, a molecule of the element is formed. So it's a H2. H2 is formed. The 2 hydrogens are taking part in the reaction forming H2 molecule. So this H2 is stable than the hydrogen atom. Then the different atoms combination. Here two atoms of hydrogen molecule combine with one atom of oxygen to form water molecule. See, two hydrogen and one water. So water's molecular formula is H2O. So depends upon how many atoms are taking part. For that we can have a molecules formula. Our topic is representation of molecules. So how to represent a molecule? A molecule of an element or a compound is represented by a formula. Yes, water formula. In the previous slide only we saw it's H2O. H2 is how many number of hydrogen and how many number of oxygen. There two hydrogen and one oxygen. So based on the number of atoms only we are going to give the name of the molecule as well as a formula. A formula gives the number of atoms of the same or different elements present in the molecule. Yes. For example, hydrogen molecule H2, only hydrogen is present there, but in the case of water H2O. So two different atoms are taking part. Here we have a definition of molecule. The number of atoms contained in a molecule of an element or a compound is called its atomicity. So whatever the molecule, how many number of atoms taking part. For example, now we saw water H2O. In that two hydrogen and then one oxygen. So totally 3 atoms are taking part in the reaction to get a water molecule. So the atomicity of water is 3. So the number of atoms contained in a molecule of an element or a compound is called its atomicity. It is nothing but for a compound how many atoms are present, that is the atomicity of a particular compound or a molecule. Here we have a formula of elements. We are going to see a molecule of noble gas. Why we have a noble gas? Noble gases are nothing. They won't react with any other atoms. This can be have an individual character. They won't combine with any other atoms. They are first one He. He, helium, it's a valency is 2. Neon is 10 and argon's atomic number is 8. Krypton is 36 and xenon is 54. Radon is 86. Noble gases have a full outer electron shell which makes this element non-reactive. Noble means they won't react with any other atom. So non-reactive in nature. Noble means what? It won't disturb anything. It is, for example, a statue where we place, it can be there for a longer time without moving ourselves. It won't do any reaction like that. These noble gases won't disturb any reaction. They won't react. Non-reactive in nature. So we are saying this is a non-noble gas. These gases are said to be monoatomic, diatomic and triatomic. So what is monoatomic? Here in this noble gas, helium and neon and argon are monoatomic in nature. Next, diatomic. Hydrogen, oxygen and chlorine, they are diatomic in nature. They are represented as H2, N2, O2 and Cl2 because they always combine with the same atom and then become a dual in nature. So diatomic. They won't come as a single atom. So we can say it as a diatomic atoms. Next, triatomic atoms. For this, we have a common example for triatomic atom is gas, ozone gas. We can represent in O3, that is oxygen 3, We can have a ozone layer above our earth also, so it is protecting the sun, should not directly contact with our earth. So ozone is a triatomic in nature. Here in this tabular column we have the list of elements given based on their atomicity. See, helium, neon and argon monoatomic in nature. Oxygen, hydrogen, nitrogen, chlorine and fluorine, these are having diatomic in nature. Then phosphorus, it is tetraatomic. Tetra means what? 4. Its atomicity is 4. Then last one is sulfur. It is polyatomic in nature. It has 8 atoms per molecule. So already we studied monoatomic, diatomic and triatomic. Here we have 2 atomic natures, tetraatomic, that is 4 atomicity, and sulfur polyatomic, more than 4. We can say to poly means many number. Here its atomicity is 8. The atomicity of phosphorus is 4, that is P4, and the atomicity of sulfur is 8, that is S8. So P4 is a tetraatomic in nature and S8, sulfur 8, is a polyatomic in nature. A molecule having an atomicity greater than 2 is called a polyatomic molecule. Yes, monoatomic and diatomic. More than that, we have a triatomic, tetraatomic. These we can say it as a polyatomic molecule. Example for this, O3, that is ozone, P4 phosphorus, S8 sulfur. These are, you can say it as a polyatomic molecules. Next, we have a topic, formula of a compound. So how to write a formula of a compound? The formula of a compound formed by 2 elements called a binary compound. It is obtained by transposing their valency. Here in this picture we have Na plus and Cl minus, that is Na means sodium plus and then Cl minus. So positive and negative, they are attracting towards it. This attraction we can say it as electrostatic attraction. So based on the different atoms, they are exchanging the electrons present in it. They are making a bond, so transposing their valency. So based on the valency we have a monoatomic, diatomic, triatomic and polyatomic. Mono means it can lose 1 electron, then it is combining with other element to make a compound. For example, here we have a sodium and chlorine. It is combining and give sodium chloride, NaCl. This sodium chloride is nothing but of regularly we are using those salt to taste our food. We can say it as a common salt or a table salt. There are some exceptions like H2O2. For the formation of H2O2, this exception is taking place, that is the transposing of electrons. Here we have a sum of the ionic compounds. Sodium chloride, NaCl, here Na plus and Cl minus. Potassium chloride, KCl, K plus and Cl minus. Ammonium chloride, NH4Cl, NH4 plus and Cl minus. Magnesium chloride, MgCl2, Mg2 plus and Cl minus. Calcium chloride, CaCl2, Ca2 plus and Cl minus. Magnesium oxide, MgO, so Mg2 plus and O2 minus. Calcium oxide, CaO, Ca2 plus and O2 minus. Aluminium oxide, Al2O3, so Al3 plus and O2 minus. Sodium hydroxide, NaOH, Na plus and OH minus. Copper sulfate, CuSO4, Cu2 plus and SO4 2 minus. Calcium nitrate, CaNO3 twice, Ca2 plus and NO3 minus. So when the compounds are formed, so what is a valency. See, Na plus means one electron it is removing, Cl minus one electron is gaining. So based on its valency, it is removing and gaining electron to form a new compound. Two different atoms or same atoms, they are transposing electrons and making a compound to attain a stability. Here is your assignment. Answer the following. Define atom and molecule. Give example of monoatomic and diatomic molecule. Give the atomicity of neon, ozone and sulfur. What is valency? Name a trivalent element. Children, many are doing your assignments and sending through GCR. I am really appreciating those students, but again more students, they are not at all considering about the assignments. Hereafter you must do your assignment and send through GCR. I already posted your GCR code through your class WhatsApp group. Don't forget, even if it is a classwork or else your video assignments, whatever it may be, you must submit through GCR. Thank you, children. Have a nice day.